In this Explain Everything, you will learn how to review fractions. The table of contents tells you which slide to refer to depending on what you need to do, and it extends below. There are 8 slides total. When you go to the slide that you want to learn more about a topic, make sure you press play on each slide to start the tutorial. The goal of this slide is to learn how to change mixed numbers to improper fractions. So we'll start with one that's all positive. The first thing that you do is you multiply the whole number by the denominator. So in this case, 4 times 3, and you get 12. And then you add the numerator. So our new numerator would be 14. And then you keep the denominator, 14 over 3. So here's our mixed number, here's our improper fraction, and they are equivalent. They're just written in different ways. This one I included particularly because of the negative sign. You're still going to multiply the whole number by the mixed number, but you're going to ignore the negative sign until the very end. So we're going to treat it as a positive 7. 7 times 2 is 14. We still add the numerator to get 15. So if this had been a positive mixed number, it would be 15 over 2. But because it's negative, we just drop down that negative sign at the end. On this slide, you're going to learn how to change mixed numbers back to improper fractions. In order to do that, you take your denominator, which is 4, and you see how many times it will fit into the numerator. So 4 can fit into 13 3 times, because 4 times 3 is 12. That becomes the whole number portion of your mixed number. Then you have 1 left over, because if 4 times 3 is 12, you have 1 more to get to 13. And then you keep your denominator. So 3 and 1/4 would be the same as 13 over 4. You can check this by actually changing it back. So 3 times 4 is 12, plus 1 is 13. With this one, because it's negative, again, you just ignore the negative sign. 3 would fit into 10 3 times, with 1 left over. Out of 3, because it's negative, we make it negative in the end. On this slide, we're going to add or subtract fractions with a common denominator. In order to add or subtract fractions, there needs to be a common denominator, and both of these examples have one. So in this example, we're adding. Very simple process. You just keep the denominator, we'll keep it as 7, and you add the numerators. 2 plus 3 is 5. If you can reduce in the end, you always do. This fraction cannot be reduced. The second example is a little bit trickier because we're dealing with mixed numbers. The safest route to take is to probably change your mixed numbers to improper fractions before you begin. So if you were to do that, 2 and 2/5 as an improper fraction is 12/5, minus 1 and 4/5 as an improper fraction is 9/5. Now we can keep our denominator, which is 5, and subtract our numerators. 12 minus 9 is 3. Generally speaking, I think it's easier to change mixed numbers to improper fractions. Another option that you have, and you can do this with adding as well, is you can subtract the fraction pieces first and then subtract the whole number pieces. If it were adding, you would add the fraction pieces first and then add the whole number pieces. The problem you run into in this example, if you do that, is if you're trying to subtract 4/5 from 2/5, you don't have enough fifths to do it, because 4 can't be taken away from 2. So what you would do is you would borrow from the 2 and make it a 1, but we just borrowed a whole, and we're measuring out of fifths. So 5/5 would make up a whole, but we already had 2/5, so that would become 7/5. So 2 and 2/5 would be the same as 1 and 7/5. Now we have enough to subtract the fraction pieces. So 7/5 minus 4/5 would be 3/5, and 1 minus 1 would be 0. So I don't have a whole number piece there. So I still get 3/5, but you can see that with the borrowing part involved, it's a little more complicated. So a little bit safer to change them to improper fractions. On this example, we're going to talk about how to add or subtract fractions without a common denominator. So on this problem, since the first denominator is 9 and the second denominator is 3, we actually can't add or subtract them yet. We have to adjust and make them have a common denominator. So when you make a common denominator, you multiply. So I can change a 3 into a 9 by multiplication. So I'm going to keep my first fraction as 4/9, and I'm going to change the 2/3. And to do that, I would multiply 3 by 3, which would get me a 9. But then the golden rule, whatever you do to the bottom, you have to do to the top. So I would also multiply 2 by 3 and get a 6. You can see that if you were to reduce 6/9, it would go back to 2/3, so that's a good thing. And then we would add across. 6 plus 4 is 10. Keep our denominator, 1 and 1/9. As long as it's simplified, you're in good shape. On the second example, again, the approach that I would take is to change those mixed numbers into improper fractions. Remember, when there's a negative out front, you ignore it until the end. So negative 4 and 1/6 as an improper fraction would be negative 25 over 6 minus 2 and 3/4 as an improper fraction would be 11 over 4. My two denominators are 6 and 4, so I'm looking for the smallest number I can change both of those denominators to using multiplication. So the smallest number I can think of is 12. I can make each denominator 12. To make the first one 12, I would multiply by 2, which means I have to multiply by 2, and I would get negative 50. And to make the second fraction, have a denominator of 12, you multiply by 3, so you also multiply the top by 3, and you get 33. Because you're doing a negative 50 minus 33, I think it's in your best interest to change that to plus negative. So now we're going to keep our denominator, which is 12, and then negative 50 plus negative 33. When you add negatives, you keep the sign and add. Negative 83 over 12, and then I could change that back into a mixed number. It's going to be negative 6 and 11/12, because 12 fits into 83 6 times, which gets you as far as 72, and then there's 11 remaining to get to 83. On this slide, we're going to learn how to multiply fractions. So when you're multiplying fractions, the most important thing to remember is that you don't need a common denominator. We don't have one in either case, but that's okay. You could just multiply straight across, so I could do 4 times 27 and then 9 times 30 and reduce, but that will produce pretty big numbers. So a better option is to look to cross cancel, and what that means is not to cross multiply, but to see will anything divide 4 and 30 evenly, and will anything divide 9 and 27. So 9 and 27 are both divisible by 9, so 9 divided by 9 is 1, 27 divided by 9 is 3, and then 4 and 30 are both divisible by 2, so 4 divided by 2 is 2, 30 divided by 2 is 15. So now that I've made the numbers slightly smaller, now I can multiply straight across. So I'd be multiplying 2 by 3 to get 6, and 1 times 15 to get 15. And at this point, I would like to reduce again. So 6 and 15 are both divisible by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So final answer, 2/5. Had you multiplied straight across at the beginning, 4 and 27, 9 and 30, you would end up with this answer eventually, but it would take a lot more reducing. On this next example, we're dealing with mixed numbers. And in order to multiply mixed numbers, you have no choice, but you must change them into improper fractions first. So negative 2 and 3/4 would become negative 11 over 4, times negative 1 and 3/5 would become negative 8 over 5. Again, I'm going to look to see if I can cross cancel. Nothing will divide 11 and 5 evenly, but 4 and 8 are both divisible by 4. So I'm going to divide 4 by 4 and get 1, divide 8 by 4 and get 2. This negative sign is still attached to that 2, and now I'm going to multiply straight across. So on the top, I have 11 times 2, which is 22. On the bottom, I have 1 times 5, which is 5. I also have to follow my positive negative rule. So negative times negative is positive, so I don't need to put anything out front. 5 can fit into 22 4 times, with 2 left over. Final answer, 4 and 2/5. On this slide, we're going to talk about how to divide fractions. So to divide fractions, you change the division to multiplication, and you multiply by the reciprocal, and that means to flip the second fraction. So I'm going to bring my 2/3 straight down. It's always important to rewrite it as multiplication and not try to do it in your head. times, and then the reciprocal of 4/9 is 9/4. Again, you would look to cancel. 2 divided by 2 is 1, 4 divided by 2 is 2, 3 divided by 3 is 1, 9 divided by 3 is 3. Multiply straight across, 3 over 2, which is 1 1/2 for a final answer. On the second example, again, you have no choice but to change your mixed numbers to improper fractions, so we're going to do that first. 7/4, keep it division, and we'll divide by -13/5. Now that the problem is rewritten with the mixed numbers as improper fractions, now I can change them to multiplication, and now I can flip that second fraction. One thing to notice is that this negative sign was originally attached to the 13, and I actually kept it on the top with the 5. I could have brought it to the bottom, and I could have written it down here, but there's really no reason to do that since there's only one negative sign, and I generally think your eyes tend to see things easier that come first. Now I'm going to multiply across, especially since I can't cross-cancel anything. Nothing divides 7 and 13. Nothing divides 4 and 5 evenly. So I'm going to multiply across, and I'm going to get -35, negative because I have a positive 7 times a -5, positive, negative, which makes a negative, and 4 times 13, which is 52. And that's going to be my final answer. It can't be reduced. On this slide, we're going to talk about how to simplify fractions. So the main idea here is that if the numerator and the denominator are divisible by the same number, it's not simplified, and we need to divide to get it into simplest form. So 24 and 36, ideally you want to look for the biggest number that will divide them both, and in that case, you could divide both 24 and 36 by 12. So you're dividing top and bottom by 12, and you would get 2/3. That was one-step simplification. It's also possible you might look at 24 and 36 and say, oh, those are both even, so I'm going to divide them by 2. And you would get 12/18. But then you would just need to continue reducing, so maybe you would then say, I could divide by 6, and you'd get 2/3 this time. So simplifying might be more than a one-step process. The bigger the number you use to simplify, the quicker you're going to get to your final answer, but you can get there in more than one step.